To simplify exponential problems like this, the first thing to do is to express each base, with a variable exponent, in terms of its prime factors. In other words, 18 is written as 2 times 3 squared, 36 as 2 squared times 3 squared, 50 as 2 times 5 squared, and 100 as 2 squared times 5 squared. From there, we apply the laws of exponents. When raising a power to another power, we multiply the exponents. To simplify from here, we need to factorize by taking out the highest common factor, both in the numerator and denominator. At the top, we take out 2 to the x times 3 to the 2x. And at the bottom we take out 2 to the x times 5 to the 2x. All that is left to do now is to cancel common terms, and express the answer in simplest form, which is 3 over 5 all to the power of 2x. Problems involving large numerical powers cannot be solved using a calculator, as they don't have enough memory. So to solve or simplify problems like this, we apply the same principles as before, by first expressing each base in terms of its prime factors, and thereafter apply exponent laws to further simplify the problem. The next step is to express each power in terms of the smallest power, which is 3 to the 2002. So, 3 to the 2005 is written as 3 to the 2002 plus 3, and 3 to the 2003 is written as 3 to the 2002 plus 1. We now break up the powers by performing the reverse of the first law of exponents. In other words, 3 to the 2002 plus 3, equals 3 to the 2002 times 3 to the 3, and 3 to the 2002 plus 1, equals 3 to the 2002 times 3 to the 1. We can take out a highest common factor of 3 to the 2002 at the top, and simplify from there, leaving the answer as an improper fraction. When solving exponential equations, the aim is to have single powers on either side of the equation, where either the bases are equal, or the exponents are equal. To solve for x, we will need to isolate the exponential term, so the first thing we do is divide both sides by 5. Thus 2 to the x plus 3 equals 16. Although we now have single powers on either side of the equation, the bases are not equal. So we express 16 as 2 to the 4, since the base on the left is 2. 2 to the x plus 3 equals 2 to the 4. We can now equate the exponents since the bases are equal, therefore x plus 3 equals 4, which means x equals 1. When required to solve an exponential equation that does not involve equal bases, we can either use trial and error by using a calculator, or we can use logarithms. Logarithms are only introduced in grade 12, so we will use trial and error to solve this exponential equation. Before we get to that though, we will first get an idea as to the possible values of x. Since the exponential term is 2 to the x, we will list the first few powers of 2. 12 lies between 8 and 16, so we know that x is some value between 3 and 4. Since 12 lies directly between 8 and 16, we will start with x equals 3.5. Note that just because 12 is exactly halfway between 8 and 16, it does not mean that x is exactly halfway between 3 and 4, as we are dealing with an exponential term. 2 to the 3.5 is approximately 11.3, which is nowhere near 12, so we will try x equals 3.6. 2 to the 3.6 equals 12.1, which is much closer to 12, but we can still try get a better approximation for x. 2 to the 3.55 equals 11.7, which is further away from 12. We continue in this vein until we get the best approximation for x. 2 to the 3.58 equals 11.96, 2 to the 3.59 equals 12.04, but 2 to the 3.585 is very close to 12, being 12.0003. This is also the approximation we get when using logarithms. For more videos like this, hit the subscribe button in the bottom right corner of your screen. Thanks for watching.